but verify is a statement in the United States and in English that basically implies very occasionally, I'm going to come out and believe you. I'm going to believe what you tell me, but I might come back later and check on it. Now, this is a good statement, and it really applies to what you want to do in your security system. But there's one thing that I like a little bit better, and that is the German phrase for it. Vertrauen ist gut, Kontrolle ist besser. Now, for the benefit of everyone, that will be the last of my German tonight, so don't worry. Now, what I really like about this particular phrase is that it implies that trust is still good. But you also need to realize that being able to audit, being able to check, that is better. You want to make sure that before you start your trust, that you have done your due diligence. And that is what attestation is today. You are going in first, you are making sure that everything is good, and then you put your workload, your model, your weights into the system. So what I'm going to talk about today is a short refresher for those who don't know where we are on confidential computing and secure AI with Hopper and Blackwell. We're going to move into the main meat of the subject here, which is the Attestation Services, going through a lot of the what we're doing, how we're doing it, and some of our future roadmap. Now, in terms of that trust and control here, I trust everybody, but I'm also going to take control and say forward-looking statements are subject to change. So with that, we are going to go into building a secure AI system. Now, you'll notice that I'm calling this secure AI instead of confidential computing, and the reason behind that I'll go into on the Hopper explanations here. Secure AI is NVIDIA's large bubble that covers the solutions that we provide you of various threat models that you can select depending on what is right for your system. Now, when you start looking at a secure AI system, it really starts from the ground up. You have to make sure that you are choosing the correct hardware for your system. In the case of NVIDIA, our confidential computing and secure AI solutions started with the Hopper technology and have continued on into our second generation with Blackwell. Now, to take advantage of this new technology, you have to make sure that you have a CPU that's capable of running either SEV-SMP, SMPTIO, TDX, TDX Connect. And with that, it's a pairing between that CPU and GPU that builds the trusted execution environment in which you can ensure that your application, your models, your weight are secure. Now, on top of that, what you're also going to see here is it's a software stack, right? At no point during any of this should all of us be aware, am I going to stop asking, is it enough, right? So you want to make sure you go through all of this and potentially more that may come to your mind, because you're never going to go wrong with asking, should I worry about the security here? So when we look at the software stack, secure boot, you want to have signed drivers. You want to make sure you have a signed kernel. You want trusted, measured boot. You want to make sure you get from end to end here. Trusted execution environments with or without GPUs require virtualization. What operating system are you going to be running on this? All of these has varying levels of support and infrastructure for running TEEs, trusted execution environments, within your system. And then at the end here, I say, trust and reliability is not just on your software, right? You need to make sure that every point in your step of supply chain, the firmware loaded on your systems, is that still good? Is that measured as part of secure boot, or is that something you need to do out of band? Vulnerability bulletins. NVIDIA has what we call our PCERT process, where we go online and we will post any sort of CVEs, their CVSS score, and tell you exactly what the remediation is. However, that's more of an active participation on your part. What you'll see here with our attestation solution is that we are actively working with our CVEs to provide you or the relying party information about what is happening and what remediation is in a more active approach. And finally with this, when you're running with software, it's not just sitting down and saying, okay, one and done. How often do you update your software for those CVEs? How often will that vendor be supplying updates? The software life cycles are another thing you have to maintain cognizance of when looking into a secure AI system. So we had Hopper that we introduced as the first confidential GPU. And with this, what we did was we had to bring a GPU into a confidential system where the whole design from a CPU perspective was to prevent two tenants in a system from getting out to each other. And if you're an infrastructure provider, you don't want them coming into your system. However, there was really never anything other than a paper contractual promises that they're not going to come into your virtual machine, that they can access your information. Various cloud providers, infrastructure owners have provided methods around this, but fundamentally, confidential computing was introduced to avoid this. Now, the problem is a GPU is someone else coming into your virtual machine and trying to access memory. So what we did was we worked with the upstream providers, we worked with OS vendors, and we decided to help provide and work with what's known as a bounce buffer. A bounce buffer says that NVIDIA will transparently, with your CUDA application, mark memory as shared. And while you're inside your trusted execution environment, we will use software to encrypt that, stage this in a mailbox, and then let the GPU come and access it. Now, the good news is that information there is encrypted, it's signed, so if anyone gets access to it, you'll be made aware of that. Now, with this, the Hopper technology was great. You go from, like bringing in the GPU into your confidential environment and have that acceleration, bringing GPUs to markets that were not able to process this data before because of either regulatory requirements, sovereign data requirements, et cetera. Now, you might be telling yourself, software encryption, bounce buffer, unfortunately, that's the nature of the beast, but it brought that acceleration to markets that did not have it before. Now, what we had is, with the further advent and the blow-up of LLMs and generative AI, we were tasked with, okay, one H100 is not enough. I need more data processing power, and I need it for larger systems, larger models. Now, this is where I'm coming back to, why did I call it secure AI at first and not all confidential compute? The market came to us and said, I need NVLink. I need more GPUs. I need more power. And what we did was we said, okay, we will enable the NVLinks. However, the NVLinks will be in plain text. Is that okay? And resoundingly with our markets, they said, that's okay. This physical attack on a bus that is not published is fast and is now a physical attack. We had people who were willing to take that security posture, and therefore we released what we call protected PCIe. Now, you have all of the same confidential computing promises from the single GPU mode, and you'll be able to operate larger models, high-end inferencing, smaller training sets, and everything that you had from keeping the host out of the system from administrator access, or having any of the PCIe or easier interposing buses interposed, are completely mitigated with our solution. Now, at the end, this enables a balance of performance and security within our Hopper system. Now, moving on to Blackwell. We announced much more of this at GTC. I highly recommend. I had a talk there just last week going into a lot of this detail. But Blackwell basically says, you know what? We are no longer going to require that bounce buffer. We're going to be able to do inline encryption with the PCIe, TDISP, and IDE. And as long as we run with a processor, again, selecting your hardware that supports it, an operating system that supports it, you'll be able to have near line rate system on your PCI Express. With that, that removes any of that overhead from that bounce buffer. This right here eliminates that need for the bounce buffer. Now, with the multi-GPU solution, we had plain text before because the market wanted it. We said we knew we needed encryption, and there it is. So NVLink encryption will be coming in Blackwell. You'll be able to do this with the bounce buffer mode if you do not have a processor or software stack that supports that TDISP technology. And with this, from link to link, encryption will be there, allowing a scale-up performance here at rack scale solutions. For more information, check out our GTC talk when it gets posted. So now, into the topic of attestation, right? NVIDIA came through, and there's an IETF body that goes through and has created the remote attestation procedures, decided to take RATS and the S at the end of it, because I guess that was a cooler acronym. What you'll notice is that the process of attestation, as has been told here, is you will go and challenge the GPU. You will challenge the device to provide evidence, some measurements, and it needs to be endorsed, meaning it needs to be signed, and you need to be able to take that information and prove that it came from an entity in this case NVIDIA. You're going to take that evidence and you need to compare it against known golden measurements. From that, you get a result, you get details from that result, and then the relying party is the one who gets to decide what to do with that information. As you can see here in video, we are following the RFC architecture here, and with that, we're adhering to the standards of the market, making sure that you don't have to do anything special just because there's a GPU in your system. Now, looking at where these pieces are in our NVIDIA stack, you'll see that the GPU endorser of the actual attester here comes from the GPU itself. And I'll go into exactly how we endorse it on the slides here, how we sign it in a few slides. The reference values, we will be posting into a cloud service all of the reference measurements for both of our driver and our vBIOS, or burned-in firmware. And therefore, for each version of the system, for each possible SKU that is out with confidential computing, you will have a reference measurement that you will be able to deploy into our SDK to check against the values, make those claims, make your appraisal policy, et cetera. Now, what you'll see here, too, is that these tools for the appraisal policy and the verifier, you can trust our cloud. High reliability service online if you want to send everything to NVIDIA and handle it yourself, or have us handle it for you. You want to handle it yourself, we have a local open source verifier on our GitHub. You can take that as part of the open source SDK and apply however you want within your system for your own use. Now inside here, we had Mark Overby, one of our lead security architects at NVIDIA, provide an OC3 talk detailing more about this system and the cloud services. And when you get the slides, this link will send you there. Now, one of the things is we have really proudly put together what I think is a great attestation suite. This RIM service, OCSP, and NRAS, these are cloud services in a highly reliable and available system such that you can go through and access these golden measurements. Separately, you can take them and send them to our OCSP so you don't have to handle CRLs or pass those around to check the current status of whether or not these are good, bad, revoked, et cetera. And on top of that, like I mentioned before, we have inside the TEE, you get this SDK. This SDK is our front end, it's our cockpit. This is how you're going to be able to take and attest our various hardwares. This is how you can work if you want to be another verifier yourself and provide plugins for your own use. And all of these things come together to help build that trust story, whether it's you, whether it's your customers. We had Felix, we had Mike, we had many others come through here and talk about using NVIDIA services. And these are the services that they're talking about on the back end. You can use this, and we're working with our partners to make sure they use it in the same way so that you get a unified response regardless of how you ask for this information. Okay, good. There's a big enough screen up here. I was making sure we'll have this afterward, but basically when we look at how we attest, we have a few methods in which you can go through and do this. We have direct to NVIDIA solutions and what we call the attestation broker. So direct to NVIDIA solutions are one where you say, I'm going to go and talk to NVIDIA when I want to check my evidence of my device. I want to go up and I say, here's the evidence, and I want you to check the golden measurements, I want you to see if it's been revoked, and I want you to send me back a token. That's what we call the remote attestation there. Now, if you don't want to go through and dial out and have the verifier happen up there, you can bring that verifier into your TEE. The broker model here, we have our partnership with Intel. We had another talk with them about their ITA, Intel Trust Authority. We're working with other partners as well to act as kind of a man-in-the-middle service, where it will take other hardware vendors, bring them together, send that compositely up to the various entities in the clouds, and then provide a composite response. So if you need to work with other vendors, Intel, they even did mention Intel, that they would do AMD. Various hardware, they're trying to make it so that it's available for any hardware for you to use with one click. Now, the first thing that you're probably going to say here, too, is, well, it's security. What about air gap? Well, the good news is we have a solution for that. This is introducing what we call NVIDIA Trust Outpost. This is a Helm chart that you can deploy into your system here, either locally inside the confidential VM or within your intranet. And its responsibility is to dial out at your pace, at your methods, to grab that RIM service as well as the revocation status of your system. It will then hold this and act as a server such that the attestation can go and talk to it instead. If this is localhost inside your VM, so be it. If it's going to be sitting in the intranet on some protected subnet, totally fine. If you just want it so it's available for higher reliability because of the number of nines or uptime you need, or regionality, sovereignty, you can do that too. And the good news is with all of this here, this lets you take more control of your system on how attestation happens. And with this as well, you're going to find yourself that, well, what about my environment? Maybe it's different. The license that we have for this allows for customization. It gives you the code for this. It gives you the ability to have some support from NVIDIA to get this integrated into your system. Now, when we go through, we said, OK, here's what we can do. This is what attestation is. What are we measuring? What do we look at? How does this answer come back to you? The little lines here make it a little hard to read, but you'll have it. I'm not going to go through all of these. Fundamentally, these are the measurements that are endorsed. We are measuring things at boot time. We are measuring things at runtime. We have different methods of looking through various components to find out what everything we have looked at in our internal reviews, customer feedback, and said, these are the things that are going to be important when we do attestation of GPUs. Now, with this, we'll just keep this. You can look at the slide. You can ask me over in the vendor corner if you have more details here. But these are all measured here and included in the RIM files. How do we measure it turns into not just storing it into a bar 0 access and being able to just grab this. We do root of trust here. This FSP is what are called functional security processor, and this is the root of trust of measurement. This is what happens during boot. It measures fuses, it measures the microcodes, puts it into an RTS, root of trust of storage. Now, when you load your driver, you're going to come in and you're going to be able to access, after building an SPDM session, the root of trust of reporting. This whole flow here is basically making it such that after you've validated a secure handshake, you'll have endorsed evidence that you can then take and run through the SDK to make your attestation response. Now, the certificate chains. NVIDIA's got a few of them across our company for various places. The two of the day are going to be our device certificates and our measurement chain certificates. Our device chains have unique keys and certificates that are burned into each individual GPU, maintaining a unique identity, and therefore, however, being able to chain back to NVIDIA. The measurement chains, as I alluded to before, are going to be for our drivers and our firmware, things that can be programmed, mutable things. And what you'll see here is every time we do a public release for a CC-based system, you'll have a RIM associated for that firmware and that driver. Now, the device certificates here. We have identity keys. These are unique to each GPU. These are burned into a fuse and then destroyed after manufacture time. We can't get them back. The public version of this is basically stored offline, which is used to help validate that chain of trust. And we take and create an IK cert, which is also fused into the GPU. Now, when we go and use this, this turns into the ability of being used to sign an attestation key, right? This is generated at boot time. You never want to have these keys used for multiple things. Your certificate should be telling you one thing, and if you need to do something else with a derivation of that, it should be different. And that's why we have this attestation certificate. With this, what you'll see is the AK cert is signed by the IK private. Put that into the signature, which is used to sign the endorsed evidence on the way back. So with this, you're able to see via the device chain how the evidence that came back to you is chained back to the NVIDIA root CA. Now, how do we make sure this happens for local verifier for the NRAS? In the driver, we cache the L1, the L2, and the L3. There you go. If you run this into the cloud, that's where it is. You run it locally, these are cached on your system. So you can still provide with an air-gap solution or an offline local verifier the certificate chaining. Now, in the measurement files for the driver here, we basically say production chain 1. You can find this when you go look at our run an attestation on your system here. The L2 is the family. This is Hopper, H100, H200. We also have Blackwell, the RTX 6000 Pro, right? These are things that are going to be attested to, but they'll each have their own L2. In the unlikely event we have to do a big revocation, it will limit the blast radius of revocation. The L3 is going to be features. Right now, it's confidential compute. There's also use cases where maybe I don't want to use confidential compute, and I just want to check the status of my firmware. I want to check the status of my driver. Was there a CVE that would just affect what we believe should happen with regular operation? This is something where I was telling you before, we're bringing the CVEs to you as a notification, and you can make a decision there rather than having to actively go check as security engineers. And then our L4, which is the termination leaf node, this is just for the version. Driver X plus 1, driver X plus 2, firmware X plus 1, X plus 2. Built so that if there is revocation, the blast radius is limited. Now, the outcome of this attestation, what happens when this happens? Now, ideally it passes, right? Measurement's great, drivers revoked, no security things, and that's 99% of the time, thank you very much. No. Okay, we're gonna have, there's gonna be some outcomes that everyone's worried about saying, I don't want you to take my workload offline, please. And that's what I'm here to tell you about. First thing we do here is driver lifecycle. NVIDIA has a lifecycle in which you will be getting security updates. We call these new feature branches, SLBs sometimes. We have a long-lived branch, and we have a long-term support branch. What that means is if you get, for example, we have driver 550 out. 550 has 12 months of security updates. We guarantee ABI and API compatibility. This is meant to be what you guys think when you think of an LTS security update branch. Long-term support, again, we right now have 535. This driver has 3 years of support and security updates, so you can just get updates, fixes, CVEs. Now, our driver certificates are set to expire 3 months after the final update. What happens when what happens when that expires? You get to decide. Okay, and I'll go into the second one here, revocation. We have a CVE. We've identified that there's something wrong that could compromise your system. NVIDIA is always going to be the source of truth in terms of where we believe the security vulnerabilities might affect you or your end customers. We use standard CVSS scoring. We have PICs, as we call them, piloting commands. Every software team understands the impact now of attestation at NVIDIA and confidential computing. The idea here with this CVEs is that there's a new threat actor in town, right? It's no longer just malicious software. You now have to, like I said before, have to worry about where your system is housed. Who owns the hardware? Who has access to the system, right? Is it the infrastructure owners, versus those external entities? Now you have to figure out that we are protecting not just against the standard breaking out of a VM. We need to make sure that the owner of that machine is not getting in here. And with all of this, the relying party uses an appraisal to say, what do I do when there's a problem? And if there's one thing to take away, because I get this question a lot, NVIDIA will never forcibly terminate your workloads. So the idea here is that if you fail for a revocation or you don't want to update your driver, that's okay, right? Our claims coming back to you are going to provide you information in which to make intelligent decisions. So today what we've got is the nonce, such that you don't have replay attacks between the GPU and the CPU. You have the nonce when you send your request to the cloud, and therefore that prevents any of replay attacks. We have overall attestation policy, or the attestation result. This tells us whether or not it passed or failed and what went wrong if it did fail. Again, you can see here we have the certificate validated, driver vBIOS, the version you're on. And an interesting one here that I really like is the attestation warning. There are extended flags in the X509 spec that allow us to say more than just revoked or good. This allows us to say something like certificate hold. This policy says could be good, could be bad. We're not really checking it. We're holding the status in our statement on this. You will notice that if you see this, you're probably working with an early access driver. That way you can pass your flows with debug flags when you change your policy to allow it, or have your default policy say, no, I don't want EA-held certificates, right? So the idea here is that it gives you some flexibility. Going on and coming through into our future here, this is going to have the certificate expiration date. Normally something that you would just say the certificate's invalid, go buy it or go get a new one. But since we use our certificate expiration to define the life cycle of our drivers, you should be able to build a policy around it rather than having to write something yourself. You can see standard certificate statuses here, certificate reasons. We're going to put CVSS as well as remediation. These are the things that are going to be coming back from our attestation service when you ask what's going on with my system. So looking forward, right? We went over today most of what the device says. We are going to say, my Blackwell says that I have these 15 measurements, and maybe the device was expired, maybe the driver was expired, maybe it was revoked, right? But now this is at the software inside the VM level. Well, we also have provided with our firmware bundles that access all the bits and pieces of our DGX and HGX. We have FPGAs on the board. We have the EROT. We have other things on the board that have firmware, switches. Well, guess what? On our roadmap is going to be our platform attestation. You buy from an OEM, you'll be able to check that firmware. Now, with this, they're going to fold right in. They're going to use the same certificate chain. We're going to have out-of-band solutions. We're going to have using the SDK if you want to do in-band. Increased measurements here. We're not done. NVIDIA's all on board with Secure AI. We're on board with security in general, and we want to make sure that all of your stuff that everyone has been talking about this whole tournament or this whole conference is secure. Grace, the CPU. Obviously, we make it. We need to attest to it. Vera, Grace next. Gonna attest to it. Bluefield, ConnectX. We are going, if we make it, it's going to be attestable. And with this, flexibility and platform chaining, we've gone into some of the more advanced features here where we can say, how do I do Rego policies? How do I chain my system together? How do I integrate VTPM to make sure the system is here? These are the things that we know we are going to while providing it in a high reliability, high availability system. So when you know that when you buy an NVIDIA system, you're going to be able to ensure that you know exactly what's going on with your system at all points with security. And as we go forward, we want your feedback. We want to know how to change things. We want to make it good for you because we're doing what we think is best practices. And if you have any feedback, any comments, please feel free to come let me know. But otherwise, you know, we look forward to seeing what cool things you guys come up with in the AI world. Thank you.